Let's start with showing the basic setup here. The robot has the Pixie camera mounted on the front. The robot's processor and the display are available for use. It currently looks at a white screen, and I'm able to put various targets in the picture and vary their position. A computer, for now, is hooked up, and we're going to use that to show the initial results direct cabled. Alright, I'm going to plug it in, and you can see it did a flat field. That's the first thing the camera does. Now, let's go over to the display and show you what the robot actually sees. Let's start with the raw mode. This is the raw image the robot sees with the camera. I can wave various targets in there. I can see the brightness setting and all the setup parameters in this mode. It doesn't show any details yet. Alright, now we're in what's called cooked mode. And what cooked mode shows is the standard view, and superimposed on it is the actual data. And basically you can see it puts a box around whatever color you've selected and saved as your reference color, and identifies it on the upper left as S equals 1, which stands for red. It could be up to 3 different colors at the same time, and eventually you can do many more colors. But you can see as I move it around, the size of the block varies, and it'll pick up that and anything else red that I put in the picture, as long as there's enough light on it. You get the width and the height as well read out in the data pattern. Okay, finally, this is the last thing. This is what the robot actually sees. You can see when I move the target around, it varies its size, and as I rotate it, you can see the height change. If it's very far away, you get a very small image, and as we get closer and closer, it picks it up. The robot sees numbers, but this is basically the representation of the real world that the robot can see. For actual use, the cable is disconnected, and the data cable, which I'm pointing at here, goes into the processor, and it does all the work. I have an LCD display here, which you will be able to see that as it reads out the data. The camera is set for a focus at the target distance, which is about 2 feet. Alright, now let's turn the robot on. Again, you can see it go through its white balance sequence, and it's now ready to read the data. Let's go ahead and set the camera up so we can read the data, and I'll show you what it does with different targets. Okay, this is what it does now. We go ahead, and as we put the various targets in, the red light will light when it acquires sync, and it will display data continuously wrapping around every couple seconds. When there is no data and we just get all zeros, you see the green light light. So here's a close-up of that action occurring. I'll put the target in, and you can see that it's acquiring the data and it reads the sync. When I pull the target out, you'll get the green light. Okay, what does the display actually read now? Let's get over the display. It'll tell you that sync is found, and it reads the various parameters, and I can move it around. I can move it further away. For example, you can see the width changing as I move it further away. Right now it's 20. There's a width of 9. Now I'm going to move it closer. The width is going up. Now we're up to 31. Now I'm about 2 inches from the camera, and it reads pretty wide now, 261. Conversely, the X and Y coordinates are also read, and as I move it up and down X and Y and coordinates, those numbers change as well. So that's how we acquire the data. Here's an example of an actual grab. It says S equals 1, which is the color red, and it gives the X and Y coordinates in the field of view using the origin as the upper left of the field. The field is about 320 wide by 240 tall, and then it also gives you the width and the height of the target in pixels. All of this can be used for robot navigation. This shows other objects that can be detected as long as they're the color red or whatever color you assign. Well, that's where I'm in right now, so hopefully we'll move on from here and do some more interesting things with this data.